Ace Navigation Team Socrates was originally built in the 1960s to accommodate 10 male personnel. Today, the Ant has expanded to include the Coast Guard Cutter Wire, resulting in a total mixed-gender crew of 25 personnel. In total, the base resides on 3.36 acres of government property. The Ant has 3 primary missions that include Ace Navigation, law enforcement, and search and rescue. The major issues to be addressed include repeated flooding, with 4 major flood events in the last 10 years. There are inadequate amount of heads and showers, given that there is currently 1 restroom for a 25-person mixed-gender crew. Finally, there is insufficient workspace, asset space, and storage space. The more minor issues include no existing boat ramp, hotel services for the CGC Wire, machinery housing, and the separation of the current administration space and boat maintenance facility. Our revised scope of work statement is as follows. This team will address the issues regarding insufficient administrative space, workspace in the boat maintenance facility, sufficient restroom facilities, and insufficient storage space. If and only if those issues are addressed, will the group address the issues of the boat ramp, hotel services for the CGC Wire, housing for the crane and forklift, and a multi-mission building that includes both the administrative space and boat maintenance facility needs. Upon project completion, the CAPSTONE team will submit a 35% design that addresses at a minimum the major issues faced by the Ant. The deliverables will include a materials list, visual renderings of the proposed design, cost estimates, and civil work. A final report that encompasses the individual details of these deliverables and the decisions we made along the way will be presented to the stakeholders.
As you can see, a multitude of different things went into our decision matrix. Once we completed the weighted matrix, we saw that option A, leaving the building as is, was the worst option. Option B, renovating the base, was the second best option. And then option C, to completely redesign the building, was our best option. Here are the decision matrix factors that we considered. Any further questions, I'll be more than happy to answer.
For our first iteration, we had a separate administrative building and boat maintenance facility building that meets the 100-year flood level plus 1 foot. As you can see from the pictures, the administrative building is on a raised platform, and the boat maintenance facility building can house both the crane, forklift, and the 2 small boats, as well as all maintenance and ready locker gear. For our second iteration, we went kind of with the same concept of having 2 separate buildings. The administrative building is on a raised mound compared to the boat maintenance facility building. Again, both are large enough to house a crane, small boat, and forklift. Now, the reason we didn't go with this iteration or anything like it is simply the fact of the geotechnical challenges that we would face with having a building raised up on a mound, especially during flood events. Also, to build to the 100-year flood level, we'd have to build a mound 9 feet above sea level, and that creates a lot of technical issues. So for our third iteration, this is really where we got the idea of having a combined boat maintenance facility building and an admin building with lofted storage for flood events, still having that roomy boat maintenance facility bay that can house a crane, forklift, and both small boats. As you can see, the administrative space is on the 2nd floor, and on the bottom floor is the boat maintenance facility bay, as well as ready storage lockers and heads. For our current iteration, we took that design a step farther. We made every room up to the space allocation manual standards. If you'll notice on the pictures on the right, you have one building has a floodable section to the 10-foot level. That whole area is designed to be flooded, and it meets the New York State standards as well as Coast Guard standards. As you can see here from the elevation views, on the right-hand side on the 2nd deck is the administrative space. On the left-hand side at a height of 15 feet is the lofted storage bay, and that'll include two sliding garage type doors to allow for quick and easy storage before a flood event of all materials in the boat maintenance facility bay. So you can use a forklift, and move pallets of stuff 15 feet above where the flood will occur and keep it dry, and that'll greatly increase flood resiliency and reduce the time it takes to get back to normal missions. As you can see here, the top left picture, you have the proposed administrative space. Again, this is just a very rough rendering here. On the right, you have that lofted storage bay. In the bottom left-hand corner, you have the boat maintenance facility bay looking down. And in the bottom right, you have a head facility. There will be 2 of these, each with 6 toilets, 2 showers, and 3 sinks.
Based on our current iteration of the building design, we made a rudimentary cost estimate. What this estimate includes is the walls, floors, roof, windows, doors, stairs, carpeting of the admin building, and the steel frame of the building. What we will include when we have our final presentation include the foundation, furnishings, excavation, fence around the base, the boat ramp, hotel services for the wire, demolition of the building that's there, temporary services. So again, this cost estimate is very rudimentary, is pretty much just the shell of the building that we have right now. So this cost estimate was done using RS Means 2012 as the reference. These references were put into a spreadsheet that was constructed by Commander Nakagawa, and it includes the reference number for RS Means, so you can refer back to it, the cost per unit, and the total cost of each aspect. Each thing is then added up, inflation is added, and the final cost is given. So looking at the spreadsheet, we have our inputs here. It gives basic information about the project, basic markups, location factor, which is also found in RS Means, and the most important aspect, the time factor. So based on RS Means 2012 and a construction start date of January of 2025, and assuming an inflation rate of 3%, we are able to, again, mark up that final cost and give a better estimate of what the project will actually cost. So the way RS Means works, it divides each part into a division. So division 3 is concrete. You can see here just different kinds of concrete. We have our foundation mat information already put in, but there's no cost right now because we don't know. We haven't designed the foundation quite yet. But going into division 4 is masonry. So this is for the exterior wall. Next, division 5, metals. So this is that steel frame, the stairs, the base layer of the roof. Division 7, thermal and moisture protection. So that's the roof and the insulation. And Division 8, opening. So that's the doors and windows. Division 9, finishes. So that's the drywall and carpeting. And then all those are put into this final spreadsheet, which includes the overhead, profit, bonding, and then the location adjustment factor, and finally that inflation cost, which right now we're looking at about $1.5 million for the building shell. And we're looking probably at about double the cost for everything else. So maybe around $3 million, just very, very rough estimate.
Now on to the sewage cost estimate. In our initial iteration, the sewer main option was too expensive to be practical. However, we are continuing to relook at it and tweak it and see if we can't bring that price down. Our different alternatives that we looked at, as I mentioned, was 1, the sewer main, a holding tank, a leach field, peat filter, sand filter, an advanced wastewater system, mount system, and an incinerator. As you can see in green, the option that we are favoring is the advanced wastewater system. This is due to different regulations and restrictions on the system as per New York State regulations.